Welcome to MEI Numerical Methods Solution of Equations 2. In this video we'll be looking at one more aspect of the fixed point method. Here we're going to be looking at a method known as relaxed iteration, which is a systematic way of improving on a given rearrangement that we may have found. We start by considering a weighted average of the function y equals x and the function y equals g of x, and we see that if we substitute alpha for x, then because g of alpha equals alpha by definition, it turns out that h of alpha equals alpha. In other words, h has the same role as g, and the function h of x could be used in place of g of x if that gives a better result. Now here we have a graph of g of x equals x cubed minus 1, which is a rearrangement that we considered in an earlier video and one that didn't work. So we can see that the gradient at alpha, i.e. where g of x intersects y equals x, is greater than 1, and we've got lambda equal to 1, which means that h of x is going to equal g of x. So the two graphs are the same, and if we make lambda smaller, we can see h of x emerging, and as we make it smaller still, we see that the gradient is reducing at the point of intersection, and then when we get down to lambda equals 0, that means that h of x equals x, and if we reduce it further, so we've got lambda is minus 0.05 now, and we're now within the favourable range from minus 1 to 1, so we want to try and get it as horizontal as possible, and so that's fairly good. That's lambda equals minus 0.25. Now we can also investigate the effect of changing lambda in a spreadsheet, and I'm using k instead of lambda here. So with a value of 0.2 we can see that we don't get any convergence, and that's as we expect, because we saw previously that if k was, or lambda was greater than 0, then we were between the curve y equals g of x and y equals x, so that the gradient of h wasn't going to be within the range minus 1 to 1. But with a negative k, such as minus 0.1, we can see that we've got some convergence, and the convergence is even faster with minus 0.3. And notice, by the way, that we've got the cell B6 there with the cursor on it, and that has that formula up there. So that's the formula for h of x. So that concludes this video on the fixed point method, and we'll be comparing the various methods in the next video.